Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back again to online NPTEL course on structure, form and architecture, the synergy. In the last lecture we have discussed on the advantages of truss and space frame for different uses, different application as like for the bridges, for the buildings and for large span structures. Similarly, now there is another structure added to this category, that is the folded plate structure. So, today our focus at lecture number 28 will be your folded plate structure. So, let us get started. Now, before like discuss about the folded plate structure and its component, its technical detail, let us understand some of the folded plate structure which do exist in our nature. So, this is basically a palm leaf, okay, and here we can see that nature, that how it is being made, and like the application sometimes even for the hand driven fan, we use this leaf when it is get dried up and it is giving a good stability. This is one, and if you really have experience of that, those edges they are quite stiff and you can it can really hold a good load on top of it. If we just make it flat, if I make this section flat, so it is nothing but a very thin plate where like applying load will make the bend, but where I just, this is option 1 and option 2, I just make a fold. So, it is all of a sudden it will increase the capacity of resisting the load on top of it. Similarly, the structure that also we have, that is the she shell. So, in this case also we see that particular structure which is make it more stiff and very strong for like, which will act as a protection for this particular creatures in the nature. So, we can get inspired from that, we can develop something. So, in case of like a single piece paper, if you try to just hold it, so it will try to bend. So, you cannot really hold it like this, but if you just try to just make a fold and again hold it, so it can have the capacity to take the load. So, let us just do not go by this particular sketch and we have to believe it. So, we just try this out. So, I have a very plain piece of paper. This is a particular cartridge paper you normally use for the drawing sheet. It is little bit thicker than the normal Xerox paper, but then also whatever we have just set, whatever I have set. So, based on that, so I am placing this in front of you and try to hold it from one edge. So, it is very difficult, like if I want to hold it like this, I cannot, okay, because of the self weight and because of non availability of the end support, it is having this particular deflection. Now, even if we just try to support it, okay, from both the end, then also we will get the bending, right. Now, in place of that, I just not make a fold, just give a notch here and now it is stable, right. So, if you can see from this direction, it is stable up to certain distance and again it is trying to get this particular bend, and now I can put a load, like I can put this pen. So, it can easily hold it. If I just put something bigger than that, So, it is not able to, because I can understand it is not. Now, in that case if I just make a fold like this, now it is more stable. Now, if I want to put this load, okay, then also it is heavier than that, but I can definitely increase the load more than that. So, this is just a slide changer, I put it there. So, it can hold this load. We cannot imagine this can be possible with a paper when it is having no particular fold. Like that I just want to improve that. So, I can have this kind of folded plate, it can easily be made with the same kind of paper, okay. And now I just want to test it. So, now if I want to put this particular duster, see no deflection, okay. And now if I remove it, this is basically a stone and it is very heavy, you can see. Now, I just put it there, see again there is no changes, and not only like it is giving support to my hand, but if I want to uplift it as well, that no such support, then also it can hold it. So, this is advantage of the particular folded plate. Now, if I want to make it more complicated, like it is a single fold and definitely we do not have a end support, this is another made of that, it is a later aim, just coincident. So, now if I want to put this load, so it can easily hold this load, but which is normally if we just consider the thickness of this particular paper, it is not possible. Now, replace this paper with some good material like some concrete, some timber, it can do excellence to carry the load and for a long span as well, because for this kind of span if we just give support end to end, like I just put this to wall and then I want to hold it. So, let us see how it can. So, I just try to demonstrate this. Okay. Now, see this is again stable. So, it is possible. So, now move on to the next thing. So, basically folded plates, what exactly it is, that I have just shown very simplistic form, but here you can see various form made of paper. So, it is related to the origami where like different fold can give you different result, and here it is basically the formation, the form that being created, and in all cases you can get that some volume being created. So, this particular volume being created, this volume being created which is having no other obstruction. So, this is advantage of the folded plate structure. So, what exactly it is, the folded plates are assemblies of flat plates or slab. So, plate or slab is alternatively being used, inclined in different direction, definitely it may be inclined in this or it may be something different, maybe members are not equal as well, and rigidly joined along their longitudinal edges. So, basically when you have this paper, okay, we just divide it and just make a fold. So, the same paper is folded, squeezed and then carry the loads without need of additional supporting beams. In most of the cases folded plates combine slab action and beam action together. What exactly it is, like whenever in a folded plate load being applied. So, first it will transfer the load through the shorter edge and then here you have the support. Now, as because we have multiple such, so the connecting members also get some balancing out the resultant reaction to that. The thin inclined beams of greater depth, whenever you make it increase the depth, it will be you are more rigid, it will give you more stiffness. I give you another example, say for like you are studying, you are on a study table and just you want to rest. So, you can just place like this, right. So, in this case like if you try to speed it, so after certain time you will fall, but if you just make it stable like this, so that will give you more stability. You do practice or you just test it and you will get the similar result. So, when you make it very flat, when you actually decrease the depth, so it will not give you much steepness compared to where you have larger depth. And then sometimes this particular layer, they are stabilized and then it resist against the your buckling. So, whenever you have this member again, so it has certain certain level of carrying the load, and as because it is having some self weight, so it can also be flattened. So, for that if you just fix both the end with the beam, then this will be more active. So, this is another advantage of the folded plate. So, that can be developed. Now, coming to the fold thing, again the edge are formed and this is basically the steep edge, and when you just make it multiple. So, we have end support to be provided here and then the edge support at the end where you can use some truss, we can use some beam as well, and the span being like this. So, the span that you have to create in this direction where you have multiple members in this direction. So, only in one direction you have to put here this particular edge support or edge beam can solve the purpose of holding the end load. Now, again the similar thing with the support, this is a single sheet can have the bending. When you make the fold it can hold some load, but when you add more load, the way I just tried with a lighter one and the heavier one, and then if fall, but if you support this end condition, then it can again can resist more load onto that. Now, this is basically the bending in fold plates cause top compression and the bottom in tension is similar to your truss, and then it will tend to flatten out due to gravity load. So, how you can solve it out? You can give support from this edge and which can stop. So, it is basically the flatten out due to gravity load or the applied load to this, but this can help it to still intact. So, here it is basically the folded plate structural behavior, how it happens. So, load applied on this. So, external force are transferred to the shorter edge first, and then the reaction that generate that is divided between the adjacent elements. So, the component will be divided, the vector will be divided, that load, the vector analysis, or you can get this distribution, and then finally, the force is transferred to the supporting columns. Now, in these sketches which has been taken from a book that is mentioned here also as well, structure in architecture. So, in this case it is just the formation where the folded plate, how it being formed from a single paper. This figure 2 where it is being shown how the load being distributed at this particular shorter edge, but at the same time with the span what we have is basically the shear. We have the bending shear as well as the axial shear, and in order to stop that, what you need to do, we have to put the edge support. So, it can be of the option 1 which may be a just some frame, or maybe it can be a truss, or just it can be a edge beam to support it, the way like I have shown here. Okay, and this is something what is showed that it is equivalent to this particular space where like if I have this member, then I just cut this portion and I can make this fold. So, maybe the area, the volume that like area that can cover. So, within that I can make more rigid, it can hold much more load to that. So, it is again a optimization of the structural section, where this can be converted to the folded plate, as because previously also we have discussed, whenever we have this rectangular section. So, if you see the bending force, so there also the outer fiber will get the maximum stress, but at the inner portion or interior portion is having under stress, means which is not able to carry that. So, then we can go for optimization of that, and the I section is one of the result of that. So, we can go with this folded plate. Now, dependency, the how folded plate will be efficient or not, it will depend on the pattern of folding. So, it may be very regular folding or it may be something different. So, half fold and maybe it is eccentric folding. So, here you can see different kind of folding being placed. The geometric basic shape that will take, it may be a rectangle or just simple fold, or it may be a triangulation by which you can accumulate and can make a geodesic dome kind of structure. The material, definitely the material plays important role to take upon the decision of the shape and pattern, because ultimately it, the safety is structural safety is one concern, and for that, like it may be concrete, may be timber, may be plastic, may be glass, some corrugated sheets being also made with this pattern. So, this case, like the material used for the construction also the it will depend, materials will affect the decision on the type of the folding plate that take. The connection of the different folding plane is another important thing. So, it may be of simple edge to edge connection, it may be something like where it is more flat connection. So, this corrugation can also be possible where something flat is being done, or maybe it is something which is very much eccentric in that. Design of end bearings, whether we will go for supporting it with a continuous wall or just the support like a column. So, and then the edge beam is being supported with a truss or a beam. So, that depends depending on that folded plate, the characteristics that will depend. Now, the materials, as I mentioned, wood can be used, steel is definitely be used, then reinforced concrete will be a very cheaper if it is being made for like mass scale application. Aluminum can also be used to reduce the weight of self weight of the structure. Plastic, glass can also be used, some corrugated sheets and all already available in the market in form of folded plate. Now, coming to the types, so basically it is being divided in three types. One is the surface structure, one is basically making a frame or portal, and then you have the spatial. Now, in the plate surface, that means only the roof instead of flat. Now, we have this particular folded plate done. So, this is representative thing, and where the end will be supported by maybe a column or something. At the same time, where we can have a frame. So, the whole structure being folded. So, here if I take this example, so this is the same member getting the fold, the roof and the wall as well. So, this is basically the category number 2. So, which is very similar to the folded plate frame structures into this category, and the spatial folded plate is basically getting a different form. Like this is one option where we can get different kind of folded dome, some different kind of geodesic dome can be formed with this. It may need not to be only the triangle, but it can go with the pentagon, hexagon combination, or else it can be some different formulation, but with proper calculation that can give us this kind of results. Application of folded plate, definitely it can be used at the roof structure for stadium, or maybe many cases some railway stations. We can have this kind of structure, or maybe for the parking, many cases we can get this kind of umbrella roof structure, like basically if you get, so this is holding a particular span. So, this can be possible. It can also act as the wall structure. Here you can see that how the folded plate being used, will get pictures of that as well. Then it can also be used as a floor. This is something interesting, where like if you have some insulation or some services to be taken between the floor, then we can use this kind of system. So, where this hollow part not only basically reducing the material, but also it will help to run all the services. So, this can be of this floor structure, or else sometimes nowadays we can see this kind of stair as a folded pattern. But again the application can be of more, like even some of the cases in construction for the sheet pile, we also use this kind of folded plate, which will give the stiffness to resist against the lateral force. So, there may be all the stranges that we put for the sheet pile in the interior area. So, then we can have this particular sheet pile as the folded plate. Now, we will focus on some of the examples and try to understand the beauty of using this folded plate, and many a cases is being used for the churches and chapels. So, here this is the example of Church of Notre Dame, and it is the example from France. This is the exterior view of that. You can see that how the wall is getting that particular fold, and this is basically the interior. Now, the interesting part of that with the fold is a nice application of those glasses to welcome the light from outside. So, this ambience inside is really interesting. So, this folded plate, the outer structure looks very pleasant, and interior like ambience and the experience is even better than that with the application of folded plate. And this is very famous if you search folded plate architecture. So, this will be the first result that you get. This is Air Force Academy Chapel in USA, and again it is nice example of like if you just compare with the typology, it is not the roof, not the wall itself, like it is a triangle, but the fold and all other thing you can get it somewhere, like how the fold being made in this particular structure. So, and this is the nice interior view, where the end is supported with some steel members, and it is one of the greatest example of the successful use of folded plate structure. Move on to the next one. This is Yokohama International Terminal, where most of the terminal buildings they need huge span to be covered without much restriction because of the heavy flow, and also have a good feeling of the volume. So, either they can go for the space frame or maybe the arches or the sail structure, but this is something where the folded plate being placed as the alternative, and the final output is in front of you. It is looking amazing with this particular cut with a very nice line, and you can imagine the span that it holds without any vertical support. So, this is again a successful application of folded plate. Now, coming to the Temprodome, that this example I have given long back as well. So, this is one multi-purpose arena, and again the structure being made, the outer structure is basically the fold, and here along with your straight line, that finally it is also taking a shape of a curve, and this is the interior that is also very well decorated. This is forming a form of like some petals kind of ambience, and it is very much regular, and it is formed in a circular form. So, this is another example of the folded plate structure, which is looking very good and solving the purpose. It is basically the corrugated sheets nowadays we use for the covering. So, this is available with some instead of tin or asbestos, nowadays we get this particular form, and it is being placed as the wall as a folded plate. So, the example in that category like the folded plate at wall. So, this is another example added to that. This is the Saint Rita. This is again a church, and here you can get this particular nice very simple, very much simple structure, just the fold on it, and then you get this nice ambience inside with a skylight at the top. Now, coming to this, this is the State Farm Center. This is the assembly hall in Illinois campus. This is making a folded plate domical structure. So, this entire sheet being made with that, and this is something where like special form of folded plate structure that being placed here. This is sports center in Switzerland, and you can see that how beautifully it being made, not only the roof, but as well as the wall. So, this is the category where the frames, not only the roof being used, or maybe the flat surface, but here it is making the portal instead of a very typical post beam connection. Here it is getting your folded plate connection in all the direction, even the roof, even the wall, and you can see that solid void, especially at the night time. You see this particular representation where like the solid void and application of the dark, the use of this concrete and the illumination, it is giving nice view, that rhythm being maintained, and this is very important for folded plate structure. When you arrange those plates, you need to maintain proper geometry, proper symmetry if it is required for the structure, then only you can get the desired result. So, application of folded plate structure being used in multiple areas. So, we have seen churches, we have now the sports arena, and then we have a multipurpose hall there as well. Now, this is a bigger application of that folded plate structure, a very light structure. You can see that how this being made. This is a stadium in sports stadium in China, whether like where this entire thing being covered with semi translucent material, where the light can easily penetrate, but it can also provide the shade to the spectator watching the sports activity. So, this is again a beautiful application of the folded plate, how it is being made, and here the glass material being used. It is also possible with the use of the steel and glass, we can go. Always it need not to be timber, or maybe it always to be like made of your concrete, but also the glass steel we can have this application. Coming to the advantages of folded plate, we have seen the advantage of the folded plate. One is very light because of the reduction of the thickness of the slab. Useful for long span without obstruction. This is similar to the space frame, but yes, here also we can apply the same reduction in material and resulting reduction in dead load and construction cost as well. So, the moment you reduce the thickness of the structural member, definitely it will reduce the dead load, and that material cost definitely reduce the construction cost, provided that you are applying it the mass scale, not at very small level project, where maybe things will not really be proven right. Aesthetically pleasant, definitely the example that we have seen, this one or maybe the previous one, maybe the daytime or night time, it is giving really nice view point of the architecture that being created, the interior space being maintained without any compromisation, and also the light and shade part into it. Here also it proves the same thing. Coming to the disadvantages, like framework is difficult. Definitely when you make this structure, it should be very accurate, as because like the load will transfer to the each adjacent member. So, say I want this to be very much uniform. So, all the connections to be very properly executed, then the shuttering to be very much appropriate, and also it needs supervision and skilled labor as well. So, that is the point that we should look into. This is not exactly the disadvantage, because to get something really great we have to do this, but still like compared to the traditional post beam which can be easily erected, it needs some more attention to get the desired result. Then accuracy in form work or shuttering is just I mentioned, that is very much required, because the shuttering, the way you make, the final outcome will be same if we use the concrete, because concrete will take the shape of the shuttering, the form work you give accordingly that will. If there is some undulation, and then the concrete will take the same thing. So, we will not get very nice experience, nice view from the inside, but more than that, that may lead to the collapse of your entire structure, which is also true. Like in the previous lecture we have discussed about the space frame, where like it is very beauty that the small members connected together will have very good resistance, but any failure at any part of that member will be a catastrophe for the entire structure. So, as true for this folded plate structure as well. And then the problem is there as well, the increase in rise and definitely the folded plate, but in order to get this, it is contradictory to each other. Like definitely if you increase the rise, then the total height, the effective height of the building will also increase. So, if there is a height restriction of a building, or you have to optimize the height given, you have to make multiple floors. So, this option may not be a good solution for all this, like arches, truss, this will not be, but wherever you have that particular freedom, you can easily go with that. And what is also need to be mentioned, that I probably not mentioned in the previous lecture, that is for all your truss or any pitch roof kind of construction, where the slope being maintained, or maybe it is round or maybe a pointed. So, it will not only take care of the structure, but as well as like it will also take care of the perfect drain off of the rainwater, or maybe if it is in the cold region. So, drain off of the snow. So, this is useful form that can be used for some climatic purpose as well, but also with a visual purpose. So, that synergy that we need to make between the structural form selection and the purpose of your structure and other thing, that can be easily blended. And slowly when we just started discussing about the post beam structure, and now move to this particular folded plate, the shell structure and other thing. So, we have seen that the good application and the final product, which are very famous in in the world, is really giving us nice experience, and also increase our interest to know about the application of that. And definitely whenever we get a chance to do it, especially for the student pursuing architecture. So, for them in their design, like wherever like we can see get a chance to design a parking lot, or maybe a shopping mall, or maybe a sports stadium, indoor stadium, we should definitely try this out to get a better result, because it will solve the purpose of long span, as well as it is giving some kind of aesthetic beauty, good form to the architecture. So, with this I just conclude here, and in the summary again, like what we have explained, that in place of very in state of a simple plate, if we just make it fold, so that all will actually increase those points. Okay. This is making this thing more stiffer, and then the load will be distributed, like when the load is given, it is converted to the side load, and then it is going to the edge and transferred to the support. And for that it can be of like you have the plane surface, you may have like what just I have shown, like something like with the roof as well as your wall together. So, if we just make it something like that, just mind my sketches here. I have shown you like similar to this, which is basically the frame or the portal. This is basically the flat, and the spatial is basically your this folded plate dome that some of the applications are already there. So, this is very useful, and the material the concrete can be used, but for that the formwork should be very much perfect, and if not, then if you use the steel and all, it will become little easier, but the perfect execution is required. How you join this and how you give the end support to stop the bending or the failure due to the gravity load, that how you go for the edge beam on the support, whether we support it by the wall or we entirely make the building like the example we have seen that the sports center that in Switzerland, there we have seen how beautifully they have done it. Most of the churches they have used it, and they also used those solid white thing to welcome the light to maximize it. So, there are applications that we can really think of, and we should try to apply in our design, like special for the students. They can apply in their academic design. Who are professionals, they can also think of where the purpose is done. But definitely for this kind of application, you need a little bit of bigger project, so that the cost which may be the the formwork that to be made in some module. So, that will be cost effective, and for the small also we can try with different materials, not only concrete, we can think of some glass or some PVC material to have nice look that can be done. So, these are the reading materials that you can go through, and also you can follow up the links given in this PPT, so that you can know more about this, you can know about the buildings that I have shared with you, and you can definitely add on more, and you should do that. And you just share with me some of the more examples that you found, or either you have visited the place or you have gone through some of the article sites, internet sites, and then you can add on. So, I would like to see those input from your side, and then moving to the next lecture, we will have the membrane structure. This is again a very beautiful structural system, and be very useful. We will be discussing on our next lecture, and till then, like I would like to thank you all to take part very actively in this course, and we will be meeting in our next lecture. Thank you.